Hi. So now let us see the next operators in Python, that is actually bitwise operators. Okay. So what is meaning of bitwise? So actually till now, if you see some operators, we already seen arithmetic operators. These operators actually we are using to work on actually directly values. And of course, ultimately in the system, everything we are going to store in terms of binary only. That means in terms of zeros and ones. So that is what bit, right? Now, it is sometimes necessary to work on bit level also. So that is why we have some bitwise operators. So what are those bit operators? Let us try to understand. So the first one is AND operator. So here in mathematics also we have this one. So that is mathematical logic AND operator. So when AND operator is going to give result true or result as 1, if both of them is 1, then output is 1. So that is what we can represent this one and with this ampersand symbol. And then two operands are required to perform this operation actually. So for more better understanding, let us see one simple example. So that is, for example, A is 5. So in this case, we have actually A5. So what we did is 5 we expanded in terms of binary with length 8 bit actually. So that is why actual 5 is 101, but because its total length is 8 bit, before 101, prefix must be 5 zeros actually. And then another operand b is what actually here is b equal to 6. So 6 if you try to write down in binary, it will become 110, and prefix must be 5 zeros because we have to represent in 8 bits. Then AND operation, if you perform, what is going to happen? Let us try to understand here. See, this is what. So if you perform AND operation here, A and B, here if you observe, when it is going to give output as 1 and when it is going to give output 0. So that is very simple. You can see if both inputs are 1, then output is 1. You can see here. If at least any one of the input is 0, then output is 0 actually. That is what normal AND operator working, right? So same thing here we did. Now this whole thing, if you convert into again in decimal number, that will become 4, right? So that is what you can observe here. Is it clear? So this whole thing is, if you convert into in decimal, that will become 4. So this is what actually AND operator is doing. So let us try to observe this one with a hands-on session. So here, for example, A equal to 5 we taken, B equal to 6 we taken. Then let us try to print this one, print A and B. Then what it must return? So it is going to return that result is 4. So here you can see. So let us try to print this one. So output is what actually A and B. So if you print now, so you can see output is 4. So that is what our observation even here also, right? Okay. So actually this operation is not going to change any A value or B value. It is going to return. It's like addition or subtraction, same thing. Okay. So for example, C equal to A and B. Now that C value, let us try to print here. So C. Now if you print this one, what is going to happen? Same thing, C equal to 4. But A and B values are not changed. Okay. So this is what AND operation is doing here. Okay. So next operator is OR operator. So what is OR operator? Same like this one only, but its operation is different. At least one input, if it is 1, then output is also 1. If both inputs are 0, then output is 0 actually. So that part you can see here with example. So A equal to 5, if you write A in binary, so 5 zeros followed by 101. Then B is 6, so 5 zeros followed by 110. Now, if you perform OR operation between A and B, what is the result? You can observe even here also, same thing. If at least one input is 1, then output is 1. You can see here 1. Here both inputs are 1, so output is 1. But in these cases, inputs are what actually? Zeros only. So that is why output is also 0. So that is what actually happening in this case. So let us simply change the operator here. So OR operator. So then let us try to print the result. Then what is going to happen? So result is 7. You can observe that 3 ones are there, 3 continuous ones is actually what actually is 7. So that is why output is also 7 here. Okay. And then next operator is XOR operator. So exclusive OR operator we can say. What is meaning of exclusive OR operator? In the inputs, any one of the input only have to become 1. Is it clear? So if you want to understand this one clearly, you can see here. For example, A equal to 5 and same thing B equal to 6. Now what we did is, if you perform XOR operation between A and B, what is the result you can observe? See here, in this input 1 and 0, only one of the input is you have 1. See, all inputs must be exclusive. Okay, same input should not be there. That is what simple. So here 1 0 output is 1. So and here also 0 1 output is 1. Okay, and now if you observe here, both of them is ones actually. That is why output is 0. And even here also both of them is 0, so output is 0. So that is what actually happening in case of XOR. Okay, if both inputs are same, then output is 0. If both inputs are different, then output is 1. So let us observe same thing with this example actually. So A cap operator B, that means we are performing XOR operation between A and B. So what must be the result? So let us see here, it is 3. So that is what here you can observe. So 6 zeros followed by 1 1 meaning is what actually it is 3 only. Okay, so this is what another bitwise operator. And then if you see the next one, of course that is very simple one, not. See, this is very simple one. What it is doing actually, it is making zeros into 1, ones into zeros. So that is what try to observe with a simple example. So A equal to 5. So that is what 5 zeros, 1 0 1. Then if you perform not of A, what is the output? So zeros will become 1, ones will become zeros. And then actually result is 5 ones 0 1 0. Actually in the system everything we are going to store in terms of 2's complement actually, if you know. So here most significant bit, MSB bit is 1. That means this is 1. That is why number is actually negative. Okay, these conversions actually we can see. So here if you see quickly how this conversion is happened, most significant bit, this is 0th position, first position, second position, third, fourth, fifth, sixth and seventh. So whatever be the highest position, that we will take in terms of minus 2 power 7, and remaining all we will take as positive. So this is 2 power 6, 2 power 5, 2 power 4, 2 cube, and this is 0, right? So we no need to consider. And then 2 power 1 actually, and then this is 0. Now if you calculate this one, minus 2 power 7 is what actually minus 128. So here you can take minus 128 plus, you can see 2 power 6 is 64, 2 power 5 is 32, 16 and 8. So this is 64, 32, 16, 8 and plus 2. So this is what, right? So you can see 64 plus 32, 90, 96, 96 plus 12, 16 is 112, 120, 122. So minus 128 plus 122, what you are getting? Minus 6 only, right? So this is, if you have any doubt, you just see the conversion procedure of 2's complement number, okay, into decimal. Then you will understand this one. So that is what you can observe here. Here output, we are making actually not of A. Then what it must print, let us observe here. So here you can see it is becoming minus 6 actually. Next operator is binary left shift actually. So binary left shift we will represent like this. Okay. So my less than 2 symbols we are using. And for example, you have a variable A. Okay. And how it is working, you can see here. Okay. For example, a value is 5, that is 0, 0, 5 zeros, 1, 0, 1. Then how this operator is working, you can see here. See, whatever number you here we are mentioning, that many bits you have to shift to left side. So this is left and this is right actually. You have to shift left side. How many positions? 2 positions. That means this number you are going to place it here, and this position value you are placing it here like this. These 6 bits will come at here. And what about these 2 vacant positions? Of course, automatically you will place zeros actually. Okay. Now what is the value of this one? So this whole value is actually 20. Is it clear? See, here one simple thing is there. When you are shifting left side, you are doubling the value. How and all you see? 5. If you shift one time left side, it will become 10. And if you shift one more time, it will become 20. So try to understand this in a simple manner. 5. 5 if you multiply with 10, what will happen? 50. If you multiply with again 10, what will happen? 500. So 5 you shifted 2 positions left side, right? In decimal I am saying now. So same thing in binary also. So you are doubling the value if you are shifting the bits to the left side actually. So that is what you can observe here also. Okay. So a value is 5. Then let us try to shift 2 positions left side. So that is what 2 positions left side if you shift, what is going to happen? Output is 20. Now shift 3 times. So you can guess the what value now. For 2 times it is 20 means one more time if you shift, what will happen? It will become double, right? 20 into 2, it will become 40. Let us run this and observe that. So you can see 40. And if you shift only one time, what will happen? So now 5, one time if you shift 5 into 2, it will become 10, right? So that is what 10. Even you can observe with another variable b. Okay. So b is actually 6. Now if you shift one time left, it will become 12. If you shift 3 times, now you observe what is going to happen. 12, 24, 48. Is it or not? So that is what you can observe. So how many times you are shifting left side, that many times you are actually multiplying into 2 that value. So that is what the result of a binary left shift. And now next operator. So if you have left shift means there is a chance of having right shift also. So in case of right shift, what we are doing, you can observe here. So same thing, quite opposite to this one. So you are shifting the values to right side. You can observe that. Since we written two positions right side we are shifting. Is it clear? So 0 shifted to here. So these 6 bits came to here exactly. So in these 2 vacant positions, we will place of course zeros by default. Now here also if you observe, this value is 5. When you are shifting right side, what is its meaning? 5 by 2 actually, we are dividing right side means. So 5 by 2 will become what? 2.5, but it will take integer value 2. And again, one time you divided, again 2 by 2 will become 1. So that is what even you can observe here, what is going to happen. So here you can see, because it is 6, right, it became 0. Why it is 0? 3 times we shifted, let us shift 2 times. So you can see 1. So 6 by 2 will become 3. 3 by 2 is 1.5, but it will take only 1. Or if you take b as 20, now you can check 2 times if you divide by 2, that means 20 by 2 is 10, 10 by 2 is 5. Let us observe as output that one only. Is it clear? So this is what. So binary left shift is shifting the bits to left side. That means you are multiplying, you are doubling the current value. Or if you shift right side n times, that means n times you are dividing that value with 2 actually, because it is binary shift, right? That is why by 2 that many times. Okay. So these are the different bitwise operators we are using in Python. Okay.